Welcome to 5G Hub. In this video, we will talk about 5G security architecture. 5G security architecture, same as 4G security architecture, consists of transport stratum, serving stratum, home stratum, and application stratum, which are securely isolated from each other. First, we need to discuss the first stratum is transport stratum, located at the bottom of the architecture, and the transport stratum has low security sensitivity. It includes some user equipment functions, all G-Node B function, and some core network functions such as the user plane function. These functions, excluding the user equipment function, don't involve sensitive data such as subscription permit identifiers like SOBI and user root keys. They manage only low-level keys in the key hierarchy, for example, user access keys. Low-level keys can be derived, replaced, or updated by the high-level key at the home and serving stratum. The second one is serving stratum. It has high security sensitivity and includes such core network function of the operator's home network such as access and mobility management function, AMF, network repository function, NRF, security edge protection, proxy, and network exposure function. The core network function of this stratum manage only mid-level derived keys such as AMF keys in the key hierarchy, and a mid-level key can be replaced or updated by the high-level key at the home stratum. This stratum doesn't involve G-Node Bs. And here we can see home stratum. And the home stratum, it has like high security sensitivity and includes the authentication server function or AUCF and unified data management UDM of the operator home network, as well as the USM in the user equipment, and therefore it contains sensitive data such as SOP, user root keys, and high-level keys. This stratum doesn't involve G-Nodes B or other function of the core network. And third one or last one is application stratum, and it's closely related to service provider, but hardly related to operator network. The application stratum involves 5G applications that similar to 4G applications need end-to-end security assurance for services that require, for example, high security in addition to transport security. For example, mobile payment requires end-to-end security assurance as this stratum, even if transport security is guaranteed on the 4G network to ensure the security and correctness of the transactions, for example. Now we need to understand what are the network access security, IIII, IV, and so on. For example, let's start by I, or network access security. The set of the security features that enable a user equipment or a mobile equipment to authenticate and access the security through the network securely, including 3GPP access and non-3GPP access, and in particularly to protect against attacks on the radio interfaces. In addition, it includes security context delivery from a core network to access network for the access security. Specific security mechanisms include bidirectional authentication, transmission encryption, and integrity protection. Second one is network domain security, the set of security features that enable network node to exchange signaling data and user plane data. Network domain security defines security feature for interfaces between access and the core network and between home and serving network. And the separation between access and the core network is as clear as that in 4G. For interfaces between RAN and the core, specific security mechanisms such as IPsec can be used to provide security separation and protection. Let's go for the third one, user domain security. And the set of the security features that secure user access to mobile equipment, Like mobile equipment uses internal security mechanisms such as PIN code to ensure security between the mobile equipment and Universal Subscriber Identity Module or USAM. Fourth one, we can call it application domain security. And this is a set of the security features that enable application in the user domain and in the provider domain to exchange messages securely. Security mechanisms of the application domain are transparent to the entire mobile network and are provided by application provider. Last one, and one of the most important one, is SPE or Service-Based Architecture Domain Security. The set of the set security here features that enable network functions of the SPA architecture to communicate within the serving network domain and with other network domain. These features include network function registration, discovery, authorization security aspects, as well as protection for the service-based interfaces. And SPA domain security is a new security feature in 5G. And service-based architecture forms the basis of the 5G core network to ensure security between user equipments in the SPA and security mechanisms such as transport layer security or TLS and open authorization are needed here. Thank you for watching and see you in the next video.